Alright, this is a video for 2HT about chapter 3, and it's going to be about the things you learned so far. So we're going to do something with a graph, something with a formula here. And I'm going to end with a difficult exercise. That's exercise 25. So we're going to do it in the end to see if everybody understands it. First, I wrote down a linear formula. Linear means that if you draw it, it's going to be a straight line. So if you draw a graph like this, then it will either look like that, so it goes up, but of course the line can also go down. I'll tell you when that happens in a moment. It always has a number in front of x, and that number is called the gradient. And the gradient tells you something about how the line moves. So does it go up or does it go down, and how quickly does it go up? This number is called the y-intercept. And that number tells you where it goes through the y-axis, because the y-axis is the vertical one and the x-axis is the horizontal one. Over here I have the computer, and I filled in a formula over here. See the formula, if it gets sharp, hopefully you can see it. Yeah, the formula is 3x plus 1, and I drew it over here. Because the gradient is 3, you can see that if you go 1 to the right, you go up by 1, 2, 3. See that? And then you go 1 to the right, and then you go up by 1, 2, 3. The other number, the 1, here, that's the y-intercept. So you can see that this one intersects the y-axis over here at 1. So that's how a formula works. Let me tell you, if I fill in another formula, and I also make this one 3x and then minus 2, it's my camera has a bit of difficulties with getting sharp on the screen, so it's kind of annoying. But you can see that if two lines have the same gradient, they both have 3x, then they are also parallel. See that? They both go in that direction. So again, the gradient tells you how much the line goes up or down, and the other one tells you where it goes through the y-axis. And if the gradient is negative, so if I put a minus in front of the 3, then you'll see that the line goes down. So if you go 1 to the right, you go 3 down. So this is the basics for linear formulas. Then with some of the exercises, you have to make the formula if you know the graph. So I made a graph over here. So you know this is the graph. And now we have to make the formula that belongs with this. So first I'm going to write down that y equals ax plus b. And we know that a is the gradient and b is the y-intercept. And then we need to make the formula for this line. So we're going to calculate what a is, and we're going to find out what b is. Well, b is the y-intercept, and that one is usually pretty easy to see, because you can see it goes through the y-axis there. So the b is 60. Alright? Then, the a is the gradient. Now to calculate the gradient, you have to do the following thing. I'm going to write down vertical divided by horizontal. And what that means is, we need to take a look at 2 points. I'm going to take a look at that point, and I'm going to take a look at this point, and then we're going to compare those 2 points with each other to see what the vertical change is if you go from here to there, and also what the horizontal change is. Well, we go from 60 to 0, so that means that the vertical change is minus 60 because we go down. The horizontal change, here x is 0, here x is 15, so the horizontal change is 15. So the outcome of this is minus 4. So what this means is if you go 1 to the right, you go 4 down. 1 to the right, 4 down. Now this goes in steps of 5, so it's pretty hard to see what happens if you go 1 to the right, how much you go up or down. That's why we calculate it like that. So now we can write down the formula. The formula is minus 4x plus 60. And that's the answer. Now sometimes you have to be careful though, because sometimes there's, instead of an x, there's a different letter there, and instead of a y, there's a different letter there. It's like an a and a t. And then your formula would have been a equals minus 4t plus 60. Alright, so to repeat, if you want to make the formula for a line, then you first figure out what the y-intercept is, and then you calculate the gradient by taking a look at 2 points, so these 2 or 2 other points, but I don't have a grid here, so I can't see any of the other points. Then you do vertical divided by horizontal, then you know what the gradient is, and then you write down your formula. Alright, 2 more things. I want to do this, and then I want to do the difficult exercise 25. This is an additional question that you should be able to answer by now. If you don't understand, I'm going to explain it now. It says, is this point on the graph of that one? Okay, so we have the graph y equals 2x minus 1. Now you could draw it, but we're going to solve this exercise without drawing it. Now the question is this point, is that on that line or not? So what you need to do is take the 4 is the x, right? And we're going to fill the x, we're going to fill that into the formula. So there you get y equals 2 times 4 minus 1 and then we're going to calculate what it is. 2 times 4 is 8, minus 1 is 7. Now, because the 7 and the 5 are not the same number, that means that this point is not on the graph. And let me show you why. If I make a sketch here, if you fill in 4 in the formula, so let's say that this is 4, the outcome is 7. So that means that this point is on the graph, right? Because we filled it in, the outcome is 7. Now we also know the y-intercept is minus 1, so that could be like over here. So if we make a straight line through these 2 points, then this is the graph. So this is point 4.7. Now point 4.5 is below it. It's over here, right? So that means that it's not on the line. Now if the outcome of the formula were 5, so if these two numbers were the same, then your conclusion is yes. But now, is point A on the graph? No. Okay, so that's how that works. So if you have a point, you need to check if it's on the line. Just fill it in and see if you get the same outcome for y. Alright, moving on. Now we have a difficult part in this chapter, and that's exercise 25, also 26 and 27, but I'll explain that later. Here we have lines L and M, and they are parallel. The formula for line L is y equals 5x minus 7, and line M passes through that point. And we need to generate the formula for line M. Alright, so I already have a paper over here. I already wrote something down. So what we know is these two lines, they are parallel. So line, this one, has the gradient 5. So if it goes 1 to the right, it goes 5 up. Well, the other one, this is the line for L, the one we need to make, so it looks like that. Right. We already know the gradient. The gradient is 5. And the gradient is 5 because these two lines are parallel. And we saw over here, if two lines have the same gradient, so let me change the minus into a 3 again. If two lines have the same gradient, then you see that they are parallel, right? So if these two lines are parallel, then A must be 5. So then we want to figure out what is this B then, right? I don't know what the B is. We do know that this line goes through that point, because that's what the question says. The question says line M passes through point A. So we're going to take the x, this is the x, and we're going to take the y, and we're going to fill that in. So the x we're going to fill in like over there, and then the y we're going to fill in over there, and the a, we're going to fill that in over there. So let's fill all of that in. Then we get 9 equals, a is 5, so 5 times 4 plus b, and then we can figure out what b is, because 5 times 4 is 20, and you need to add something to 20 to get 9. So that means the thing you need to add is minus 11, because 20 plus minus 11 is 9. So now we can finally write down the formula for line M, and the formula is 5x minus 11. Now that's kind of a difficult question, but hopefully this makes it more clear. Thank you for watching.